to our video presentation today regarding the Illinois FirstNet project. My name is Bill Springer and I work for the Illinois Terrorism Task Force, and I'm the system architect for the state of Illinois on the FirstNet project. So let's talk a little bit about the technology of FirstNet, at least at a high level. One of the first questions you have to ask yourself is, if we've already got the commercial cellular networks, why are we going to go to all the effort of building a parallel network just for public safety? And the big thing is capacity, like I said earlier. Day to day, the commercial cellular networks are suffering from congestion because, again, they've been very successful in getting a lot of users on their networks. However, that does cause congestion. One of the things to remember about the cellular networks is they're a shared bandwidth model. There's only so much bandwidth to go around, and the more users that are on that network, the smaller and smaller chunk of bandwidth they get. So that's where the congestion comes in. If the networks are not very crowded at the time you're trying to use it, you have a fairly large chunk of bandwidth that you can use. If there's a lot of users on there, many users on there, those chunks start to get smaller and smaller, and it gets harder and harder for users to transfer data. One of the things we've also seen is occasionally carriers have been limiting bandwidth. If you'll notice, every so often you'll see a press release or a news item about a carrier where they talk about what were formerly their unlimited bandwidth plans. They've had to cut those back and throttle the data for some of their users because they've been so successful getting so many customers on there. They can't handle everyone using the network at the full capacity. The drawback to public safety on the commercial networks is they don't provide priority access to public safety. Again, it's a shared bandwidth model. They have a lot of valid reasons for doing that, and it's the most efficient way to serve all their customers as fairly as possible. Everybody gets an equal share, and it's first come, first serve. The big thing that FirstNet brings to the party is capacity dedicated to public safety. That's key. In an emergency situation, the problem gets even worse. To public safety, it appears that the commercial cellular networks have failed, but they really haven't. What's actually happened is nothing is actually broken, they've just gotten overloaded. If we think back to the Boston Marathon bombings from a couple of years ago, if you remember the news reports, they were saying that the feds told the carriers to shut their cellular networks down right after the explosion. That's not actually what happened. What happened was those networks got extremely busy very quickly. Everybody tried to use the network at the exact same time. So you had people that were get on the phone and they called their loved ones to find out if they're okay. They started texting each other to find out if they're okay. We had people that were photographing the scene and uploading the pictures. We had people that were videoing the scene and trying to upload the pictures. And they were all doing this at the exact same time, which caused the network to go into overload, and it pretty much locked up. What we saw was that even in using texting, which is one of the things that people think of as a very reliable way to communicate, even texting got overloaded and text messages weren't getting through. In the Boston Marathon case, that congestion lasted for probably 3 or 4 hours before the network started to get back to normal. Again, it's that capacity dedicated to public safety. What FirstNet does is it keeps us from getting caught up in that data traffic jam. We'll be able to send our own data without having to contend with all the other users. Now, we're not saying that the FirstNet network will never get busy. It probably will at some point, but at least we control our own destiny. One of the things with FirstNet is we have local control over who uses the network and how they're able to use it. When we talk about these sort of things in this network, you'll see terms like priority and preemption, and it's really two different things. Priority is simply how traffic is ranked by urgency. So just as an example, we can take police, fire, and EMS traffic, and we'll rank them at the highest priority levels. And then at the medium priority levels, we might have public works and transportation and utilities at a medium priority level. And then a low priority level might be administrative traffic or administrative agencies. Priority really doesn't mean anything as long as the network is not at 100% capacity. Once it tries to go over 100% capacity, that's where preemption kicks in. And what happens is the lower priority traffic is held up by the network and held back to let the higher priority traffic through. So if the network is only lightly congested, the lower priority traffic is affected. If it's very congested, you start seeing the medium priority traffic being affected. And all it's doing is holding that lower priority traffic in a queue and just holds it up until the network gets uncongested, and then it starts sending it back through again. So traffic is not actually lost, it's just held up and delayed for a little bit to let the higher priority traffic get through. So what's LTE? You've seen this term a lot when we're talking about FirstNet. It's a term used a lot by the commercial carriers. It stands for long-term evolution. It's a widely used industry standard. It's used all around the world by carriers as their data standard. It's a widely used standard. It's used in all countries and used in the commercial cellular networks. It's also known as 4G. As the network has advanced over time, we've had 2G, 3G, 4G, so on and so forth. LTE has a very well-defined technology roadmap. The standards body that controls how LTE works knows what the features and functions are going to be today, and they've planned out how the network is going to evolve over the future timeline. So we understand what features and functions are going to be available as time goes on. This also means that if we go from 4G to 5G, let's say, the standards bodies make sure that these things are compatible. So we don't have to take all the equipment and throw it away and buy all new 5G equipment. It's just minor upgrades in the equipment to keep it up. Also, LTE is very high capacity. It's one of the most efficient protocols for taking a lot of bandwidth and sending it over a fixed amount of spectrum. This is why the carriers use LTE. So why would we use LTE? Well, at the top of this drawing, you'll see the little garden hose up there. That's just a single voice channel representation. And that's the most efficient way to send voice over the radio is by a very narrow band channel, or the garden hose illustration that we use up there. But if you want to do more, if you want to do video, if you want to do internet access, if you want to send building plans or maps, you have to have a bigger pipeline. And that's where LTE comes in. That gives us that 10 megahertz broadband pipe. And it allows us to do all these things that we can't do on a single narrowband channel. Now, it's important to note that our pipe, that 10 megahertz bandwidth, is the same bandwidth that the commercial carriers have. FirstNet has an equivalent amount of spectrum to operate in, an equivalent amount of bandwidth. The big difference is there's far fewer users that are going to be on FirstNet than there are on the commercial networks. So we have a whole lot more room to operate. Each user should get a larger chunk of spectrum to operate with than they would operate on when they're on the commercial networks. This is just a representation of the public safety spectrum. As you'll notice, public safety FirstNet broadband has two 10 megahertz chunks. We just happen to fall next to Verizon Wireless that has two 11 megahertz chunks. The key takeaway is that we have the same type of spectrum, the same amount of spectrum as a major commercial carrier. We have a lot of room to operate. We have that same amount of spectrum, and we can do an awful lot with that in public safety. So FirstNet supports a lot of strategic data applications. Obviously, the text-based data lookups that we're looking at today, like the driver's licenses, license plates, and so on and so forth. FirstNet also starts to enable things with geographical information systems. For example, vehicle tracking from GPS. It also allows you to start looking at things like sending pre-plans or utility plans or maps or building layouts. You can start sending these over a network now because we've got the bandwidth available to do this. If you're on a commercial network and they happen to be in a congested time, it's hard to get these large files through, but if we have our own dedicated bandwidth, we can get large files like we talked about here through the system. Also video. Video is probably going to be a big driver for FirstNet. Video is one of those things that if you've never used that in public safety response before, once you've used it, it's very hard to go back to try and do these types of response and management, the incident management, without the video. It's very useful. You can have the helicopter videos, you can have video on portable platforms from the, out in traffic, the camera platforms and so on and so forth. There's also other things like telemetry. This would be patient and responder biometrics, where a first responder could be wearing a telemetry or medical telemetry. So if we take the example of a firefighter, they can be monitoring his heart rate and monitoring his body temperature. Someone could be monitoring that remotely. If he starts to get overheated or his heart rate gets too high, they can put a call out to say that fireman needs to come out of there, his health is in jeopardy. So there's a lot of things that you can do. If you have the bandwidth, you can do them because you can get the information back and forth. So for example, it's remote views of fire behavior. One of the things we can look at is when a fire truck pulls up to a commercial building fire or a chemical plant fire or things like that, you could put a camera up on a mast and actually monitor the fire behavior and send that video off that scene back to somebody who's an expert on that type of fire. So they could give you maybe advanced warning if the flame behavior changes or things start to look a little bit out of sorts. You might get a warning before something goes really bad. Another thing that we've looked at is this is an application for live streaming video from the ambulance to the emergency room. In addition to the voice communications between the ambulance and the emergency room and the telemetry, the EKG and the heart rates and things like that. Now we can put a video camera in the ceiling of the ambulance pointed down at the patient. So now the emergency room doctors have more information that they can look at. They can actually see the patient, see what he's doing, see how he looks, and just get more information. It helps them when that patient shows up at the hospital. They know a lot more about him than they did just from telemetry and from the audio from the EMTs. Also, remote access of a dashboard camera from a squad car, the dash cam video. Normally, dash cam video is all local. We record what's going on around that squad car out the windshield locally inside the squad car. When we need the video, we go back to a central location and pull the video out of the trunk or wherever the recording unit is at. What FirstNet would allow you to do is you'd have the bandwidth available in a situation where you needed to. You could access that camera in the squad car and actually see what they see out the windshield. For example, this graphic here is a video from one of the tornadoes in Moore, Oklahoma from a few years ago. Right now, like I said, that's all done locally. Now you'd be able to get that video out. So if the officer's in a pursuit, you can see what the officer's seeing as he's driving. If the officer's not responding to a radio call, you'd be able to access their camera and at least look out the windshield and see if there's anything going on that you need to take a look at. Closer coordination with utilities. We talked about this a little bit before. With FirstNet, you'd be able to send photographs and videos directly to the utility company so they can see what kind of problems that they've got out there with their lines. It allows them to understand what's wrong and what they need to bring to fix it very quickly, rather than having to go out there and blind and say, well, we've got wires down, but now with a video or a photograph, they can actually see how much wire is down, if there's any poles broken or things like that. Also, construction zone monitoring, monitoring the traffic in construction zones. Construction zones are a very dangerous place to drive. There's a lot of fatalities and a lot of crashes there. One of the reasons they're dangerous is a lot of times construction zones create traffic backups. And one of the things that traffic engineers always want to know is there a backup and what's causing the backup? Why isn't the traffic flowing smoothly through that zone? One of the things you can do is take out a portable camera platform like we see in this picture and start videoing the traffic patterns as they're going through this construction zone. If you try and do this if you're using the commercial cellular networks, you find it's very difficult because if the cellular network gets very congested in that area, you can't get the video through. Again, it's that shared video issue, and as your chunk of allowed video gets smaller and smaller, pretty soon you can't get your video through. FirstNet allows you enough bandwidth to be able to take that video and take it from a remote location and send it back to a traffic center or a dispatch center or to where the traffic engineers are so they can see what's going on in those construction zones. Emergency management is full of ideas and ways that you could use FirstNet to get information. One of the biggest things with emergency management is, again, they're very data driven. They rely on a lot of data and a lot of information to make those decisions. FirstNet, we feel, would help those emergency management agencies out greatly to be able to transfer that information from a remote location wirelessly back to a centralized location. There's a lot of uses of existing technology in public safety. Those are practically unlimited. There's a lot of things that you can do. We just don't do them today because we can't predict if we're going to have enough bandwidth in any location to be able to use those applications. All these applications depend on dependable, reliable, and adequate bandwidth. And that's what FirstNet brings along to the party, is that with FirstNet you'll have the bandwidth to do these applications and get the information back and forth. If we talk a little bit about the architecture in FirstNet, we've got four basic parts to it. The first part is the core network. This is kind of the brains of the operation. The core network is actually what decides how we get data from, say, Chicago to St. Louis. The core network handles all that data transmission. The core is also where you make the connection to the other networks. For example, LEADS, NCIC, your CAD system, your 911 system, your records management. It's also where we make the connection to the internet or any public services. The second layer is transport and backhaul. And all that is just a connection from the core network out to the radio access network, or the sites. All radio access network means is it's the towers, the radio sites, and the base stations that provide the signal out to the public safety devices out in the field. And we anticipate there's going to be a wide range of public safety devices, everything from smartphones all the way up to ruggedized laptops and ruggedized tablets. We anticipate there's going to be a wide range of devices, hopefully a wide range of pricing from low price to high priced so the agencies can get the equipment that fits their needs. So this is a representation of a typical public safety device that we think we're going to see on the FirstNet network. One of the things I'd like you to look at is technology advances, it's going to be possible to put many radios in one device. And what that means is, if you're familiar with current cell phone technology, if you've got a cell phone or a device that works on the Verizon network, it won't work on the AT&T network and vice versa. The reason is those two networks they speak different languages, so they're just not technically capable of sending information. So what these devices will have is, as technology advances, they'll have multiple radios in one device. They'll have a radio in there that can talk to the FirstNet network. They'll have a second radio in there that can talk to a public carrier, whether it's a Verizon or an AT&T or both. So they'll have the capability to operate on multiple networks. And this does a lot of things for us in FirstNet, particularly roaming between FirstNet and commercial. And this does a couple of things for us. First of all, especially early in the network, there's going to be areas where the FirstNet system is not built out there yet. There won't be a FirstNet signal. So what the device will do is, if it can see a FirstNet signal, it'll use the FirstNet network. If it runs out of FirstNet signal, it'll look around, and if it can find a commercial network, it'll jump on the commercial network to be able to still allow you to use that device. You won't be able to have all the capabilities of FirstNet if you're on a commercial network. You won't have the available bandwidth probably, and you won't have the priority and preemption. But at least if you go out of the FirstNet network coverage area, you don't have a dead device. The second thing it does for us is it allows us to bring the FirstNet service to agencies who may not be able to afford to buy all new devices. For example, if we think of volunteer fire departments, if we think of EMAs that have a lot of volunteers that work for them, small police departments, so on and so forth. If you'll recall, just about everybody who works in public safety already owns a device. And as technology goes on and people replace them, they're going to start buying these devices with the multiple radios in there. So it's entirely possible that, let's assume your volunteer fireman, he's got his own smartphone, his own device. He probably has FirstNet and commercial capability in that device at some point in the future. So what this allows us to do is, when the volunteer fireman goes on duty, he can log into the FirstNet network, and his device will use the FirstNet network. He'll have all those advantages, all the features and functions of FirstNet, like the priority and the added bandwidth. When that volunteer fireman goes off duty, he logs off of FirstNet, and then his smartphone will then jump back over to whoever his private commercial carrier was. So it allows us to get the FirstNet service to a lot of smaller departments without requiring them to buy all new user equipment, all new smartphones and things like that. So this is just a representation of all the possible things that you can connect up to the core network. Obviously, we talked about it earlier, is the state and federal data, the leads, the NCIC, there's a connection for that. You'll also see an app store on here. One of the things that we found out in this process is there's a lot of very clever people in public safety whose full-time job is public safety, but they write apps because they're technologically oriented people. And they write a lot of very interesting and very good apps that are for public safety uses. So what FirstNet is going to do is they're going to take and collect up these apps and have them available in the FirstNet App Store. FirstNet's going to do a couple of things. First of all, they're going to make sure all the apps are written to a standard. So that way that if you've got a device with an app written by vendor A, and you've got a device with an app written by vendor B to do the same thing, we want to make sure those apps are all written to standards so that all that data is interoperable between the devices. We want to make sure that my device can send data to your device and it's understood. The other thing that we have in the App Store is they want to check for malware. If you've ever listened to news reports, every so often you'll hear where somebody sneaks something into the Apple App Store or the Google App Store or whoever, and it's got malware. So you thought you were playing Tetris on your device, it was really stealing all your banking information. FirstNet is also going to apply some sort of security to those apps to make sure malware doesn't sneak through. As you might imagine, the FirstNet network is going to be a very high priority target for hackers. So network and security is going to be a big issue for FirstNet. There's a lot of things that they have to make sure of to make sure the network is secure and it's usable and we're not losing information. For example, one of the things FirstNet will have to do is make sure that my device, when I'm trying to log on to FirstNet, my device is authorized to be on the network. If it's authorized, fine. If it's not, there shouldn't be a way to get on the network by sneaking on. Secondly, once the device has been validated, we have to make sure that the user is capable, or that the user is validated to be on the network. So we have a couple different layers of security here, and we need to make sure that this network is very secure, and FirstNet has a lot of work ahead of them to do for this. This is just a view of the AppGo App Store. If you're interested in apps, it's highly recommended that you go here. There's a lot of apps on there for public safety. This just happens to be a screen printer of police. They also have them for fire, EMS. Many of them are free. Some of them are just a few dollars. So it's just a handy thing to get used to using apps in the public safety world.